Hi, I'm Alex Pault, editor at large for electronic design. And today we're going to talk about the TSMC IP Alliance Program with our good friend, Chris Morrison from Agile Analog. How's it going, Chris?
Yeah, Alex, it's going great. Thanks for having me on.
Well, you're a friend of the show and a friend of mine. Might as well have you on to talk about the organization because I understand you just joined it, didn't you?
We did, yeah. We've been working with customers of TSMC for a few years now. Our company's 6 years old, and we've been working with various TSMC processes. And as we've grown that relationship with TSMC, we've been invited to join the program, which we've just done, and it's a really exciting program with lots of the key members in the semiconductor industry involved in it.
Well, it's also part of their open innovation platform, right? I mean, they're not just trying to pull together an alliance to, fill the supply chain, as it were. They're also trying to see where it's going to go, right?
Yeah, I mean, the IP side of things is just a small part of OIP. They've also got the EDA Alliance for the tools, a Design Center Alliance for the design of full chip developments, and then I think most recently they've just added the Cloud Alliance in terms of working in the cloud with these providers.
Now, obviously, semiconductor development, chip manufacture, these are not light tasks. And the more you can focus IP on these applications to create the right solutions, the better off everyone is. Can you tell me a little bit about how the organization, the alliance, how it helps the industry, in what specific ways it helps the industry?
Yeah, I mean, I think anybody who's developing an IC at the moment, particularly if you've done it for a long time, will be the costs now appear eye-watering when you start a new development. And what the IP Alliance allows is to share some of that cost across, from my side, multiple customers, but multiple chip developments. So no one company's having to cover all of the cost. It's spread across the several people who will use a bit of IP. I think that's one of the big advantages. The other is that you, as a person choosing IP, can see the track record for it. So you can see one, that it's come from a TSMC approved vendor, which gives a mark of credibility to it. But TSMC also do some thorough checks to make sure that the IP that's part of the IP Alliance has been properly verified, properly designed, properly documented, and they keep track of when something is taped out, when it's been in mass production, to just increase your confidence that you're buying IP that is good, and will work. My background is sitting at the other side of the table buying IP. I'm not an IP guy to trade, and I have many examples in the past, and I'm sure some of your listeners were, of where IP integration hasn't gone well, and the IP Alliance is really there to try and ensure that doesn't happen, and to make it easy to integrate IP.
Integration's the big question, isn't it? I mean, it seems that at almost every level, because obviously we're always thinking of convergence on the chip, and we're always thinking about more dense and interesting functionalities, but integrating those functionalities and getting it so that they work in an optimal fashion on chip is, I mean, obviously part of the goal of this organization.
Yeah, I think particularly I focus very much on the analog side of things. The digital guys have been quite good at that over the years. But if you look at chip design, typically there's a cycle as we move down process geometries. The digital moves quite easy, but the analog is a slower process, and you end up with this a de-integration cycle where you move down a process node, the analog isn't ready, so you do the analog off chip, and then the next generation you bring the analog back in, and then you move down a process step, you put the analog out again, and it's a bit like the hokey cokey, the analog's in and out and in and out. And I guess one of the reasons for us coming on board the IP Alliance is because we, being process agnostic with our IP, means we can target things like our ADCs and DACs and LDOs, we can target that to a new process very quickly, so the customer doesn't have to deintegrate their analog. They can keep it integrated from one process to the next.
That's also an important aspect of it, right? Is design for manufacture, as it were, because it's easy to develop in a computer. It's harder to develop, in the silicon, as it were.
Yeah, and it is getting harder and harder to do that, particularly at these latest process nodes. The physics changes. It's not like back working in 250 nanometer was where I started. It was relatively easy then. Now, when you're talking about 3 nanometer, 4 nanometer, even down to 2 nanometer, as we're moving in that direction, it's a different world. And the design for manufacture, even just the design at different bits of the chip perform the process variation happens across the chip now, not just across the wafer. All of that needs to be carefully accounted for. And again, the IP Alliance is a big help with that, because it's people who know what they're doing and have been there and have done it.
It's so interesting, Chris. It really is, because at this stage, it's as much material science as it is electronics, because, well, like let's look at quantum physics. I mean, quantum computing, which of course involves quantum physics. But let's look at quantum computing. They're putting these things in cryogenic rigs. And yeah, sure, it helps the quantum stuff, but the rest of the circuit has to deal with those temperatures or near temperatures, because it would be extremely expensive to simply insulate just the processor, So you're sticking this circuit into this cryogenic situation. How do the capacitors frankly, I don't know how to build a quantum computer. Someone might say, no, the capacitors are outside the cryogenic environment. But I'm still thinking, whether it's at room temperature or at cryogenic temperatures, once you get to those feature scales, you're playing right at the edge of physics.
Yeah, absolutely. And we as a company work with some of the guys in the quantum computing space. I don't understand any of the physics. Although my good friend and next door neighbor is a quantum physicist, I don't understand what he talks about. But I do understand some of the electronics challenges they face. And yeah, designing circuits to work at just above 0 Kelvin is a very difficult task. On the plus side, now there are some companies who have cryogenic PDKs where they've tested across at that temperature range, and that's something that we're working with some customers with at the moment to try and make work. But it repeats the same thing we're seeing across the industry. Is, as you say, the physics is getting difficult. Everything becomes a materials problem rather than the electronics almost become easy.
Almost. So were there any other aspects of this that you wanted to bring up before we close you out?
Yeah, the big thing, putting my company hat on rather than my industry hat on, we see a big need amongst the IP Alliance at TSMC for more and more data converter solutions and power management solutions. And what we're trying to do is to fill that gap. There's some really great guys who do processors on IP Alliance. That's not going to be our space. That's where we're going. We're going with broadening out our portfolio of data converters and power management, and we're excited to work with TSMC on that. And I'm sure we'll have some new announcements on that in the near future.
Well, when you do, make sure you come by here and talk to us about them, okay?
Will do. Thanks, Alex, for your time today.
Oh, Chris, the pleasure is mine. And I'd like to thank everybody out there in the audience as well for taking the time to watch. We appreciate it.